Greetings, everybody. Today we're going to take a look at some examples involving those special right triangles that we've been talking about, the 30, 60, 90 and the 45, 45, 90-degree triangle. We're going to need the foldable that we made in class, as well as your regular notes, something to write with pen or pencil, and a calculator today. So remember on that foldable that we made, we were talking about the relationships that we found in the 45, 45, 90-degree triangle. And make sure in your little foldable that you have this relationship written. The hypotenuse of the 45, 45, 90 triangle is going to equal the leg times the square root of 2. We took a look at where that relationship comes from, and now it's time to use it. And in a 30, 60, 90-degree triangle, we're talking about triangles that have a 30-degree angle, a 60-degree angle, and a 90-degree angle. The relationship is different. These are the two facts that we have written down in our foldable. Hypotenuse equals 2 times the short leg, and the long leg equals the short leg times the square root of 3. So using these relationships now, we're going to take a look at 5 examples. Make sure you copy these examples in your notes near or on the page where you placed your foldable, because we're going to be referring back to that foldable to get ourselves started here. So make sure that they're near where you have that foldable in your notes. Okay, here's your first example. You do need to write down the picture or copy the picture down. It's all about the picture now. It's a triangle. We see a 30-degree angle. We have a 4 on the side and an X and a Y that we're trying to find. Okay, if I take a look at this triangle and I notice that he's a 30, 60, 90-degree triangle, I know 2 facts. I know that the hypotenuse equals 2 times the short leg, and that the long leg is the short leg times the square root of 3. So I would ask myself, how do I get this thing started? Well, let's take a look at what we actually know for a side. This 4 is the short leg. So we need to use a formula that has short leg in it. Good news is, both formulas have short leg in it, okay? So we get to choose. I think I'll start with the first one. The first formula we have written down is hypotenuse equals 2 times the short leg. So if I go ahead and plug in what I know, according to this picture, you guys, the hypotenuse is an X, the short leg is a 4, and I'm going to drop down the rest of the formula. This now says that the X will equal 4 times 2. Well, I can figure that out. The X is going to equal 8. Yes. So I already know what the X is in my picture. Now I would want to use the other formula to try to help me figure out the Y. That formula is like this. Long leg equals short times square root of 3. So according to my picture, now plugging in those values, the long leg is shown with a Y in this picture because it's across from the 60-degree angle. He would be the long leg, okay? So that Y down there is the long leg, and the short leg still is 4. And then if I put times square root of 3, now if I simplify what I have there, it says Y equals 4 times the square root of 3 is the same thing as 4 square roots of 3. So there's my X value and my Y value using my 30, 60, 90-degree triangle relationships. Here's a second example. Take a moment and write this one down. This one's a little bit trickier than the one we just did. Okay, I'm noticing again that this is a 30, 60, 90-degree triangle. So I still have those same relationships, those same 2 formulas that you find underneath your little foldable area there. We have those 2 formulas written. Hypotenuse equals 2 times the short leg, and long leg equals short leg times the square root of 3. So if I look at this, what am I given? What's the one side I know something about? This guy right here is the long leg of my triangle. And because of that, I need to use the formula that has long leg in it, because that's the only side length I actually know. So the formula that has long leg in it is the one that says long leg equals short leg times square root of 3. So now if I plug in what I know, what is the long leg? The long leg is labeled with the number 9. What is the short leg? The short leg in this picture is labeled with an X. I know he's the short leg because he's across from the 30-degree angle. And then I would drop down, the rest of the formula says times square root of 3. Now, if I look at what I have, it doesn't say x equals something. It says 9 equals x times the square root of 3. That means to get the x value or to figure it out, I'm going to have to solve for this x right here this time. So I need to divide by the square root of 3 in order to get x alone, because right now x is being multiplied by the square root of 3. I would need to divide by the square root of 3 to solve for x. To solve means to get alone, to isolate, okay, to figure out what value he equals. So the square root of 3 divided by the square root of 3 there cancels, and I would have x over here. And this is 9 over the square root of 3. But if you remember, we can't leave a square root in the bottom of that fraction there, people. No square roots in the denominator. So this is where we go ahead and we rationalize that denominator using that skill that we developed before we started this unit. We'll multiply by the square root of 3 on both top and bottom. And if we go ahead and figure this out now, we'd have 9 square roots of 3 on top over the square root of 3 times the square root of 3 on the bottom becomes square root of 9. And you should say, wait a minute, the square root of 9 is just 3. So we'd have 9 square roots of 3 over 3. This is looking pretty good, but we're not quite there yet. These two can simplify. 9 divided by 3 is 3. So my answer becomes 3 square roots of 3 for my x. So that's what x equals. So knowing that now, we should be able to help ourselves out here and figure out that y. The y is on the hypotenuse. So we're going to go ahead and use hypotenuse equals 2 times short leg. Well, now I know the short leg here, and I know the hypotenuse is labeled with a y, so we're going to fill that in. Y equals 2 times, what's the short leg here again? Oh yeah, that's this x, which we just found out was 3 square roots of 3. And so now if I simplify what I have there, y equals, multiply those two, 6 square roots of 3. Okay, so I have an x and a y again off of this triangle. The formulas stay consistent, but what we do, the math within there depends on what's given to us, okay? Here's a third example. Another 30, 60, 90 degree triangle here. This time I'm given the hypotenuse of 6. So we're going to go ahead and use the formula that has hypotenuse in it. The 30, 60, 90 degree formula that has hypotenuse in it says hypotenuse equals 2 times the short leg. That's right. So 2 times the short leg. Hypotenuse in our picture is labeled with a 6. So 6 equals 2 times, what's the short leg labeled in this picture? X, looks like. So 6 equals 2 times x. That doesn't say x equals 6 or x equals 2. We need to get the x alone, so we're going to divide by 2. And now it says x equals 3. So now that I know x, I should be able to find that other missing piece. The y is the long leg, so we're going to use long leg equals short times square root of 3. So the long leg is labeled with a y. The short leg we just found out was 3. And I'm going to drop down the rest of the formula here. So y equals 3 times the square root of 3. So y would become 3 square roots of 3. Okay, x value and y value. Now let's take a look at our 45, 45, 90. 2 examples of 45, 45, 90, and then we're done here. So looking at this picture and remembering our one formula, our one fact about these, we wrote down the hypotenuse equals the leg times square root of 2. Now remember, in a 45, 45, 90, the reason there's no long leg or short leg is because the legs are the same. It's isosceles. 2 45-degree angles mean you're going to have 2 equal sides. So with that in mind, you guys, we know right away this is 45 as well. That means this side and this side are exactly the same. So I already know before I even start this thing that x has to be equal to 10. And now I can use my facts and that finish up by finding that y value. The y is the hypotenuse. The leg is 10, and it doesn't matter which one we use because they're both 10. And then times sine square root of 2. So y is 10 square roots of 2 when I simplify. X value, y value, there we go. Okay, and our fifth example and last example. So on this picture, you might go, well, I don't know exactly what kind of triangle this is. I don't see a 30, 60, 90 or a 45, 45 degree angle in there. But you should notice these are equal. Okay, those little marks right there mean you have two equal sides. Therefore, you know you have two equal angles as well. That means this has to be a picture of a 45, 45, 90 degree triangle. Knowing that, let's use the one fact we have. Hypotenuse equals the leg times square root of 2. Now, when you look at what we're looking for here, x and y, we both need to find them, or we need to find them both here. This x, or this y and this x, they're marked with those little congruent symbols there, or this congruent marks. That means that they're the same. So all I would need to do is solve for one, and I know the other. So using what we know that and our fact that we wrote down already, let's plug in what we have. So the hypotenuse is the first thing we're going to plug in. It is labeled with a 6 square root of 2. The leg, we can choose either x or y. It doesn't really matter because they're both going to be the same value. I think I'm going to put an x there. And then I'm going to drop down the rest, square root of 2. Now remember what we're trying to do. We're trying to solve for x. X is not alone. He's got a times square root of 2 with him. So we need to divide by the square root of 2 on that side and on this side. So I'd have x equals, now notice square root of 2 over square root of 2 simplifies to 1, so they basically cancel each other out. Look at this. Same deal happening over there. That means that x is just 6. Okay, and if x is 6, that also means that my y would be 6 as well, because they're marked congruent. So that's how we use our facts about special right triangles, those side relationships, to solve problems involving right triangles that in fact are special. So using these examples, we're going to look at this further and get some good practice in so that you can use these very fluently. Thank you for taking good notes.